Image. Install the drivers. Install the drivers. Be a good card. Yes! I am so good! Look at that inductor. Look at that inductor. I am so good. This was the original. I am so good. Yes! Oh my fucking god. I fixed it. I fixed the card. I don't know how much auto editing this thing is gonna have, but I am very fucking shaking right now. Let's take a look at the AC quality. Fuck! Oh my god! Oh my god! Oh my god, that power limit! Oh my fucking god! It supports so many memory chips. Oh my god! Okay, so what you just saw was the first proper boot up attempt of this here GTX 980 Ti Amp Omega, actually. I wanted to pick up a 980 Ti for some time, basically because the 980 Ti Strix that I had, the working one, I also have a dead one. I used to have a working 980 Ti Strix that I gave to my sister because she just needed a new graphics card to work with, so I don't have that card anymore. And then I had a 1070, which I use for the same purpose, which is just like when a friend visits or I go somewhere and take my PC, I usually take my test bench, not my daily system, because that's just very heavy with all the water cooling in it and just very hard to move. And I just kind of need a graphics card to play games with. Since I now moved out of my parents' house, I left the GTX 1070 there, so I can also, so I also have a PC there when I visit them to do things with. And now I kind of needed a graphics card again that you can like play games with at like 1080p high refresh rate levels. And I wanted to get a 980 Ti for that. Because if I remember correctly, these are faster than a 1070 if you overclock them. And also they are 28 nanometer and Maxwell and not Pascal. So basically these are more fun to overclock. And I saw this card for sale for 185 euros, which might be a bit much, but like considering the current market conditions, that's pretty cheap. Also, this card didn't come like you see it right now. It actually came with a EK water block attached, like a core-only water block, but still like a water block that I probably would have sold it because it only fits like NVIDIA cards and it's pretty clunky to work with, like worse than the freeze mod block that I use as my universal water block. But I was like, hey, 185, that's like about 20 to 30 euros under the current sale price of a 980 Ti. This is a custom card made by Zotac. And I get a water block with it that I can sell for like 20, 30 euros. So I thought it's a pretty good deal. So, card showed up today. And I plugged the card in and everything worked. I even pre-checked with the seller that this has Samsung VRAM. So this has Samsung memory, which my old 980 Ti didn't have. That one was on Hynix. And for 980 Ti's, you specifically want Samsung memory because from what I've seen is in order to get like good, I'm not sure if it was core or memory clocks or maybe both. Basically, you need to increase your memory voltage to get the card to like proper clocks, like something like the memory controller in the core, which is also powered by the memory voltage, needs to be overvolted if you overclock the card sub-zero to get proper. I'm not entirely sure if it's better memory or core clocks or possibly both. And the Hynix memory you get on 980 Ti's scales negatively with voltage, so you cannot overvolt the Hynix cards because they stop working. So you need a Samsung card because those you can overvolt and they keep working. So I specifically wanted a Samsung card, which this is. He like the seller checked in GPU-Z that it is a Samsung card, and that's all fine and dandy. So I took the bait. I paid for the card, which basically this entire month's budget went into this card. So yeah, there we go. And I got the card, I tested it, I plugged it in, and it was putting out an image. It was indeed a Samsung card. And yeah, so then I was gonna take the block apart just to see like how's the thermal paste, and I wanted to put there's still someone never peeled this part of the heatsink. Huh. Yeah, so like I wanted to put my own block on it, and stuff. Yeah, and the card also came with like these heatsinks on some of the memory modules. I wanted to remove those because those are just about big enough so that they interfere with like custom air coolers, which is what I transitioned to doing my binning on. So I've been mentioning how I've been rerunning all my binning results on water cooling to have them temperature normalized, but after running a few cards I realized that that's a lot of work, like setting up the water cooling. So I decided to use this heatsink instead, which is the Morpheus heatsink, and just with two Arctic P12 PWM PST fans. And this heatsink's about 10 to 11 degrees worse than water cooling, but actually so far the cards are reaching the exact same clocks. I think I lost like 5 megahertz on one card for the high voltage tests, and everything else so far scored the same. So because this air heatsink is a lot easier to set up, I'm just gonna use the Morpheus for my binning from now on. But anyway, let's get back to the card. So I wanted to disassemble the card, just take a look at the PCB, like look at the VRM. I kind of knew what to expect because I looked the PCB up online before I bought the card, which we're gonna get into. We're gonna take a look at the PCB and everything, and I'm gonna say what I think of it. But yeah, so before I even took anything apart, I saw that, well, I can't really see it on this heatsink, but basically the screw that was in this corner, I saw there was like a little, what looked like a solder ball stuck to the screw, and I was just like, wait, what's a solder ball? Is that bad manufacturing on the water block side? Or like, because I only see these solder beads on like stuff that shorts, like it comes out of dead power stages or something sometimes. And I was just like, what the hell is that? So I took my tweezers. Are these called tweezers? I think they're called tweezers. And I wanted to see if it's like solid, like stuck to the screw, or if it's like moving. And it was indeed moving. And it wasn't a solid piece of solder. So I very quickly realized that that bit of metal that I found just randomly on the PCB next to the screw was in fact liquid metal. So I immediately went from, oh cool, I have a 980 Ti now, to, oh my fucking god, the card is maybe dead. So I removed that bit of that liquid metal, kinda hoped that, okay, maybe, I don't know, maybe this guy had liquid metal on the CPU or something, and maybe it dripped into the card and just landed there, like, let's see. So I removed the water cooling block, and sadly I found, well, I can just show. This is the plate of the water cooling block. I lapped this. You can see how I lapped this. And you can still very clearly see, yep, this thing has liquid metal fused into it. You can even see the like imprint from the core. So, the seller didn't mention this at all. Nothing. I had a liquid metal card on my hand, and you can still kind of see it here. It wasn't even making proper contact. Like the edges of the die were not covered. So I was just like, I knew the card was putting on an image. I didn't try to install drivers yet, so I got very anxious. And I was just like, oh my god. He didn't mention it has liquid metal on it, and the liquid metal application is like the liquid metal receded, like liquid metal, like it fuses with the copper in the heatsink, so it like dries up, and that's probably how the edges of the die got exposed and no longer covered. And then I found liquid metal somewhere on the PCB, and not just near a screw, like all around the core there were some little drops of liquid metal. I thankfully was able to use my tweezers to remove all of those from the PCB. They landed on my desk though, and now I have a permanent liquid metal stain on my desk. Liquid metal is, well, liquid. That doesn't evaporate, doesn't dry out, it just stays. And well, now I have several spots on my desk that just look very silvery, shiny, and just kind of dark. And I guess I'm just gonna never be able to remove those, because liquid metal, just, I've been told, you once you got it, you're not getting rid of it. So, yeah. Then I was just like, shit. Then I just hastily tried to remove all the VRAM, like memory heatsinks that were glued onto the memory chips, to check if there was like maybe liquid metal around somewhere. So there was some liquid metal around the core. Actually, let's just show that right now. Let's disassemble the card while I'm talking. So yeah, I was removing the heatsinks, and in my usual fashion, like you don't, if you get heatsinks that are thermotaped onto, like glued or thermotaped onto memory chips, you don't want to be pulling them off. You want to be like twisting them off, because if you pull them off, you usually pull the chip off with it, and at that point the card's dead. Like you're gonna rip off traces, and the PCB is just completely ruined and no longer fixable, and you can just forget about it. And well, after paying that much for a card that I might already have to fix in some way, yeah, I am not gonna risk that. Oh yeah, also it only came with one thermal pad for memory. That's completely, yeah. So you can see like these were covered by the water block, and then these had heatsinks on them. So I tried to remove the heatsinks. When I slipped, like I slipped with this heatsink that was on here, and I flicked off this inductor right here. So this is the inductor for the PEX rail, like the display drive rail that also powers the PCI Express interface on the card, and the inductor flew off. So I was just like, well, now the card's not gonna put an image, because without this rail, like I've had it that the card just starts up and like gets detected normally, but you just don't get an image when this isn't running. This card just wasn't working at all, because like I tried to read, like the inductor was only flicked off on one side, the other side was still holding to the PCB. So I just got my soldering iron out, put a bit of flux on, and then just kind of like soldered it back. That didn't work. I got like 140 millivolts on one side of the inductor and 0 millivolts on the other side, so the bar was just completely broken. Like none of the sides got the proper voltage. So I realized, okay, the inductor probably is just dead. So I removed the entire inductor, got my hot air station out, got my preheat out, preheated the card, and I just kind of scavenged through, yeah, like through donor components, and I found this inductor, which is actually a completely different case. Like the inductor that used to be here was one of a style like this, but also in the 1R0 spec, like this one. And this one's the only other 1R0 I had. Thankfully it fits the pads, so I hot aired that one on. And then thankfully the card put out an image and installed drivers. So at that point I was okay with the card. I was very confident that, okay, card works. I just got really spooked by the liquid metal. Because this was not mentioned by the seller, and the liquid metal application, like, I did a video on this. Why not to use liquid metal on GPUs, and this is exactly why. The liquid metal did not stay on the GPU. So first up, it fused with the block. Like, even after lapping this, it's like permanently like part of the block, and well, I could lap it some more, but like, you're not getting rid of this liquid metal stain. I could just lap it flat, so that at least it isn't like bumpy anymore. It's a very little bit bumpy still after lapping it for a bit. And just like, so not just did the liquid metal recede and part of the die wasn't cooled anymore, no, the liquid metal was also spilled all over the card. Like, here was a drop, there was a drop here, there was like one close to the PCI Express. The core area had everything about it, liquid metal on it. There's still liquid metal stains on there actually, but you can see at least the person who liquid metal this card had the decency to put like nail polish or whatever that is over the capacitors around the GPU. That's what the red stuff is. So at least those are protected from liquid metal because they had several spills on them that have since dried out and also fused with this red material. So yeah, I just kind of use an excessive amount of thermal paste on purpose so that this would be covered by thermal paste and just nothing would be able to ever get in there again. So yeah. So this is why you don't liquid metal graphics cards. This card was so close to actually dying. Also, there was no thermal pad here. Like, the block was just, like, the terminal was here. Like, this is where the fittings were, like the block was here, and then there were the fittings over here. Yeah, these didn't have a thermal pad on them. It's not cooling. These had heat sinks taped onto them. You can already see the coverage was also very bad on those. These ones weren't cooled at all. I don't know how long the card was operating like that. Also, this VRM was completely naked the entire time. So I'm like, yeah, just like I know extreme overclockers tend to look like they're abusing the hardware, but I am gonna be a much, much better 980 Ti owner than whoever the person was that had this card before me. So yeah, like this card went through some trauma. So anyway, that's pretty much the story of the card. I did put it on the my universal water block and then later on the Morpheus heatsink to do some testing. And yeah. One thing that I can say right away is the card is an absolute beast. It clocks at 1480 megahertz stock. That is a higher clock than the 980 Ti Strix could achieve with the strongest manual overclock that it could hold stable. That 980 Ti maxed out at 1440 megahertz, and that was the maximum, like, not daily settings, that was the absolute maximum I could push that would pass benchmarks. This card just casually clocks in at 40 megahertz above that stock. So that's a statement. Then, oh, by the way, this thermal pad is from a 580 Direct CO2. I added that myself so that the VRM would get some more heat sinking. That's not part of the standard design of the card. But yeah, so the core on this is insane. The ASIC quality is better than over 90% of GM200s. So it's a damn good core. This thing also ships with a 425 watt power limit. So yeah, 3090 is actually not the first time we got a 400 plus power limit, a 400 watt plus power limit. And also the stock voltage is like 1.23 volts, which is pretty high. So yeah, the VRM of this card definitely has to take a lot more abuse than a reference card, which actually has me kind of worried because this is just an 8-phase. It's not a weak 8-phase, like it has discrete MOSFETs, which looks kind of cheap, and it is cheap, but discrete MOSFETs are actually basically the best way to get high current handling capability per phase, as long as you keep them cool. This heatsink looks decent, and the stock heatsink has high airflow config. Like you can see, there's a lot of space between the fins. At least with the stock heatsink, this got a decent amount of airflow on it. On the Morpheus, it's a bit more of an issue. You have a lot more fins there. So I always just like put a fan over the edge of the card that like blows into the VRM heatsink and also over the memory chips, because those are completely uncooled. So yeah. But yeah, discrete MOSFETs, I Haven't looked up any datasheets for these, but yeah, I suspect that we get a decent amount of current handling capability per phase. We also have two low-side MOSFETs, which just straight up doubles your current handling capabilities from just using one low-side MOSFET. It also halves your RDS on resistance, which makes each phase more efficient. Therefore, less power losses in the VRM and therefore less heat, which makes the MOSFETs even more better at handling current, because the colder a MOSFET is, the more current it can handle. How much more current it can handle depends on, well, the spec of the MOSFET, and I didn't look up the spec for these. I don't think there is a PCB breakdown on this from Actually Hardcore Overclocking. There might be, but I don't think there is. So maybe I'm gonna make a second video where I go into the actual spec of the MOSFETs on these. But basically, this is an 8-phase, which is 2 more phases than a reference card. And the reference card is using 50 amp DRMOS components. And we are probably getting a similar amount of current handling capability per phase, probably more on this. And also just the PCB is bigger, like you can see how it's extended here, like the more mass, just bigger PCB means better cooling, the heatsink's better than a reference card, DRAM's more spaced out than on a reference card. Also that thermal plate I put on the back probably helps, like the backplate got like decently hot, even though the thermal pad is probably a bit thinner than it should be. But you can see the imprint here, it is making contact. So it's helping a bit. Sadly, I don't have enough thermal pads to like put behind the memory and memory VRM. If I had, then I would do that. I'm gonna look into like buying extra thermal pads for this. Like this should be a 2mm pad, and then the one for the back, like this one should be a 2.5mm pad. I might look up getting like 2.75 or 3mm for the back, because this one's not making that much contact. It's like barely making contact. Like these standoffs are like basically also 2.5mm, so the thermal pad is like just making contact, and there isn't really a lot of pressure behind there. So thermal transfer is probably not all that great. Then again, the backplate did heat up quite a lot in the VRM area, so it is helping something. So yeah. So the VRM is okay. There's definitely better cards like the Strix. The international rectifier version of the Strix. I have to say there's 2 versions of the Strix. The one that my sister has is a UPI version, which I think is actually using the same controller as this one. Though I'm not... Yeah, both cards are 6x2 phases. So doubled 6 phases. Because I think it's using the same controller as this card. But yeah, like the Strix are both like doubled up 6 phases, so 12 phase VRMs. They're both using DRMOSs. Then again, I think the UPI one is using DRMOSs. The IR one, because there's 2 versions. One's using a CHA 318, and then the other one's using UPI controller. And the IR version is actually using IR 3550 amps, which are proper smart, like, well, power stages. I don't know if they're smart power stages, but like those are 60 amps times 12. That's probably better than what we have here. You might get something similar here if you really, really cool this VRM down a lot. But, well, if you put like proper heat, like a proper heatsink on the back too, and then give it a lot of airflow maybe. Yeah. So the VRM isn't the strongest, which is why I was a bit anxious when I saw the 425 watt limit, because that's quite high. Because like I think the Strix card has like 300 or maybe 350 watts. This is like almost 100 watt extra on a VRM that looks weaker for the first impression. Again, I haven't looked at the specs yet. Maybe these are like some super high-end MOSFETs. Though the VRM was getting very, very hot just running the card stock. So yeah, I'm not too sure if this is these MOSFETs are that great. Because I remember seeing a couple of Zotac cards landing in some repair shops with an acute case of hole in the PCB, because there's no fuses on this PCB. Not even the PCI Express slot is fused, so this one's straight up just not fused. If a MOSFET melts down on this one and you don't have a good power supply, goodbye phase and possibly more. Yeah. Yeah. So for raw current handling capability, this is for sure better than reference, but not the best. So the IR Strix, I don't really know about the UPI Strix. The UPI Strix using some very not that great looking DRMOSes, but the IR Strix is probably better. The Kingpin 980 Ti is probably better. The Hall of Fame and all of its subvariants, like there's a GOC Hall of Fame and all that's probably better, because those have like 14 and 16 phase VRMs, I think, for the Hall of Fames. This one is like a medium quality PCB compared to those, so better than reference. But reference is bottom of the barrel, and if like your Kingpin and Hall of Fames is top, then this one's pretty much in the middle, if you ask me, for current handling capability. Then the output filter on this is not necessarily that much better, in the way that the output filter on this is pretty much just a straight downgrade from the GTX 970 Omega. So, yeah. I do have to say there is actually a 980 Ti from Zotac that also has the same name as this card, that does use a PCB much more closely resembling the 970 Omega's PCB. That one has, I think, a much better output filter than this. But as far as it's that, like, I got the original box with this, and it does say Zotac GTX 980 Ti AMP Omega Edition, not AMP Extreme. Like, it also says it on the heatsink here. So yeah, 980 Ti AMP Omega. So this is not an AMP Extreme. It uses the AMP Extreme PCB, but in fact, like the box and the heatsink. I don't know if is there actually a sticker somewhere here. Is there a sticker on the backplate? No, okay, there's actually no sticker on the card itself identifying it as an Omega. But yeah, this is an Omega. There just seems to be two different versions of the Omega, and this one seems to be the slightly watered down one, because it's just an Extreme that's probably really highly binned, which explains the very high core clocks on this one. So I think this is just like a uber binned AMP Extreme, whereas then the other Omega is like an extreme overclocking focused one, because this one doesn't really have any extreme overclocking features. Unlike the 970 Omega, which has like an LN2 mode switch, it has an USB interface for voltage control, and that sort of stuff. This one just doesn't. It's just a completely normal 980 Ti with a custom VRM design. But yeah, so the output filter isn't all that great. So you get CAN-type capacitors, and here Zotac is doing a typical Zotac thing again, because if you look closely, these two capacitors here are 16 volt 3030 microfarads, and then the rest of these are 2.5 volt 1200 microfarad capacitors. Yes, these two are not actually output filtering for the VCore VRM, these two are input filtering for the memory VRM. I was freaking out a little bit when I was measuring voltage while I was troubleshooting the card, because I saw 12 volts and was just like, wait, is my cord just dead? But then, I mean, if I was getting 12 volts VCore, then the power supply would trip off or it would catch fire. So I was pretty quickly realized that, oh, these are input filtering without even looking at the spec of the capacitors. So here we get 1, 2, 3, 4, 5, 6, 7 1200 microfarads CAN types. That's a lot of microfarads, but the least efficient way to have those microfarads. So yeah, it is a lot of microfarads, but like they are not being put to very efficient use. Then we have some multilayer ceramics and some SMD polymers. Now these are actually kind of hard to read. They use a couple different ones. I don't think these actually say the capacity on them. Yeah, I think these just straight up don't. Oh no, it says 477, so these are probably 477 microfarad ones. Same goes for the memory VRM output. So those are nice capacitors. I would have preferred if instead of having these, for every one of these, I would like to have two of these right next to each other. That would have been probably better. And then on the back, we get some more multilayer ceramics, and over here, and then over here, and then the memory gets another couple. These are different ones, 470 still, but these are different spec. These are probably all memory. Then we get one more for the core, and then we get this power boost module, which you already saw on the 970 Omega. Now this one only has one. The 970 Omega had, was it 3 or 4? I think it was 3. So these might look like prod lasers, but they're not. Under this metal casing, you will actually find 6 more SMD polymers like these. I don't know which size, but I suspect 470. Because just like everything else on this is basically 470. Same for the 970 Omega. So yeah. So this one probably has similar or more capacitance, like total capacitance, than the 970 Omega, but a lot of what was in form of multilayer, well actually, did it? I don't think the 970 had that many multilayer ceramics, but the 970 definitely had a lot of SMD polymers. And a lot of that capacitance from the 970 turned into CAN type on this card, which is just worse. Like, they do something, but they do far less than capacitors like these. And I just kind of don't like seeing that, because like the 980 Ti is much more power hungry than a 970. Therefore, having a good output filter becomes more important. And this one just kind of has a straight up worse one than the 970. Which is a bit, yeah, just a kind of bit sad. There is modding potential. You could like plop multilayer ceramics next to these. You could like plop more CAN types on the back of these if you don't mind throwing away your backplate. And then that's it basically. There's not really anything that like you could put on some SMD polymers. I don't think I will mod the card, because it's mostly meant just to like, when someone wants to play games on the test bench, which might be me or a friend, I will use this card for that. Well, I'm gonna do some Sub-Zero overclocking, that's the plan, but I don't think I will be modifying it much. I might do like a volt mod for voltage control and something like that. But yeah. One last bit about the output filter. One bit that I actually like is what they did behind the core. Now this is a thing that Gigabyte also does. And as you can see, they have actually put 560 microfarad SMD polymers behind the core. Now on a reference card and most other cards, you're probably gonna see 330s or 470s. These are 560s. So yeah, Zotac and Gigabyte have been doing that, so you just get more capacitance directly behind your core. And I also think the closer your capacitor is to the thing pulling the power, the more effective your capacitor becomes. So these are probably actually quite useful. This is a very nice thing that I like to see. Like I liked seeing that. The first time I noticed that was with Gigabyte. Like my 780 Ti WindForce. And then later also my 2080 Ti Aorus Extreme, they both do that. They have these 560 microfarads directly behind the core. And Zotac is doing the same thing. Just upgrading the capacitors. Like they I don't think the AIBs are allowed to change anything about the layout directly behind the core, but they can choose which capacitors. Like they have a minimum capacity they have to put behind the core, but they can choose to upgrade it, which they did here. Which is nice to see because most manufacturers just kind of copy paste the entire like core and memory back section like this. You generally tend to not see any customization in this area, which, well, NVIDIA and also AMD don't really allow anything, but they do allow to upgrade these capacitors, which is actually kind of rarely done. So I like seeing that. That is very nice. Yeah, I have rambled on for quite some time now, and I think I've said everything I wanted to say. Yeah, I'm gonna probably make a second video where I talk more about the components like MOSFET. I'm gonna look up the datasheet, I'm gonna look at the controller closely. And yeah, that's basically that. I'm gonna make a second video. Like, this one's too long and I can't look up the datasheet while the camera's rolling, so gonna make that in a secondary video. But yeah, I have a 980 Ti now. I really like Maxwell. Maxwell's just like Kepler, and I love Kepler. It's both 28 nanometer. 28 nanometer, like if you ask me, 28 nanometer is the best node just ever. Like pretty much all the architectures that came out of it are really, really fun to use, scale really well, like have pretty nice PCBs available for them. Yeah, so I did enjoy working with my ePowered 970 and the 970 Omega, which isn't mine actually. Well, this one is mine now. Yeah, so I'm looking forward to working with Maxwell a bit more. I'm also quite happy to get a card that I can play games with. I do actually want to keep it on the stock heatsink because I really like the way this looks. I really appreciate this look actually. I think this is one of the better looking heatsinks that you can get. I also briefly tested it. It's not actually that loud and actually works quite well. I just need like 2 more thermal pads for the memory. And because it's 2mm, which is a size that that's just kind of rare, I don't have any spares from other cards that I can use here. So I'm gonna have to source thermal pads somewhere, and then I can, use this heatsink on the card. Because, yeah, I like it visually and it performs well. And that should be pretty much it then. Yeah, so you'll be seeing some stuff being done with the card over the next couple of days, weeks, months, whenever I have time. And yeah, so thank you for watching. Hope you enjoyed my little story time session with a very brief overview attached to it at the end. And yeah, gonna be making a more in-depth video about the components on the card later. But I hope that you still enjoyed this video. Maybe learned a little bit of something about not using liquid metal on graphics cards, or some of the things I said about capacitors. Yeah, so thank you for watching, hope you enjoyed, and until next time, goodbye.